last absence na naman beload nga gihatag sa CPU. So, i-share na ko, guys. Here. Okay, so this is pneumatic and programmable logic controller subject. So the topic that we have is the electro-pneumatics. Okay. So in electro-pneumatic, guys, so this is the topic that we will be discussing for today. So is electro-pneumatic? What is the basic control system of electro-pneumatic? At the same time, what's the input devices? I know that you already have the idea about input devices and output devices, and also the logic devices. Okay, so worksheet, forget about that at this point yet. So I'll just need to talk with it with Sir Dakulara first about this worksheet. Okay. So what is an electro-pneumatic? So it is an industrial control technology that integrates pneumatic and electrical energy to generate a working device. Okay? So sa inyong pneumatics, guys, like for example, sa inyong hydro last meeting, okay, without the use of a push button, katong walay push button pa, with all the wirings that you have and connecting it to a air compressor for power, pwede compress for air, hydraulic compressor for water. Okay, so that part there, that is a pneumatic already. However, this is what we call electro-pneumatic because we need to have a push button switch, and the push button switch requires a electricity in order to execute the on and off of the switch. That is why we have also an integrate electrical on this one. So that is why it is called electro-pneumatic. Okay? So there. So muna siya, it is a control technology that integrates pneumatic, okay? So the use of air in order to activate a certain cylinder or whatever purpose that you have for whatever desired output that you have. And of course, it also integrates electrical energy to generate the working device. In order for it to actuate, we need to push the button, we need to start it, and for starting that use electricity. Okay? So these are this is the flow, okay? So you can have either air for pneumatics, water for hydraulic, and this is electronics, okay? So these are the electrical components, and these are on the left side. If you're going to face it on the left side, this is the components that we will be using in terms of hydraulics or pneumatics, and on the right side, guys, so these are the electronic components, okay? Now, let's start first with the working element. So in a working element, we have, for pneumatics, we have cylinders, the motors, components, and then on the electronics, we have electrical motors. Solenoid is conducted by volts, so it is an electronic. So linear motors are also an electronic components. Okay, so in a control element, in terms of pneumatic, we have directional control valve, even the indirect control valves, and we have also power actuators for electronics, power transistor, and power thyristors. Okay. Now for processing element in terms of logical, okay, so we have the direct control valves. It has also a logic components to it. It has also an isolating valves and pressure valves. Okay, but for electronics, we have contractors, relays, electronic modules. Okay, so these are all wirings that needs to be, if you're going to see relays, guys, there are more wirings to it, and it is conducted by electrical current. Okay, and also for input elements, so in terms of pneumatic, we have switches, we have push button actuators, limit switches, we have roller switches. And in electronics, it has also switches, push button actuators, limit switches, programmable module or program module, sensors, indicators, and generators. So this is how it looks like, guys, in terms of pneumatics and in terms of electronics. We can all see all the components you need in terms of working element, in terms of controlled element, the processing element, and the input element. Okay? Now, the basic control system is always been input, logic, output. That is in the electro-pneumatic way. So in a programming, guys, you have their input, process, output. Even in your research, in the flow of your study, you have their input, how you process it, and what's the output. Okay? But in electro-pneumatics, guys, the basic control system that we have, the process is according to input, the logic, and the output. Okay? So input, what are those inputs? We have the push buttons. We have limit switches, level switches, photoelectric sensors, proximity sensors, which we will tackle all of this on the next slides. Wait sa kaliyot, guys, kaya walang makiktigil, mas sila kasaba na ako.
Kasi ka?
Ano man? Ha?
Puro na kublo.
Suot lang. Okay lang. Uli na dito.
Ha? Uli ko ganahan. Uli. Ito. Huwag mo po.
Okay, so those are the input, guys. So these are the things that we will be discussing later on as we go on to the slides about the push button switches and all other switches that we have and sensors that we will be using for the input. And if in the process part or the logic part is what we have there is the relays, the timers, and the counters. Okay, so we already have discussed what relay is, and the last time we had our discussions. And it could be timers, guys, is one of the controllers that we have here in the control panel. So what's under the logic, guys, is the control panel. Okay, so this is decision one. That's why we have it could be logically decisions. That's why we have the or, the and the not or, and the not and. Okay, so with the use of relays, timers, and counters, this is the control panel. So whatever the settings that we set up on our relays, whatever setting uppers and the counters, that is the process that we will be doing in our control panel, and there it has a desired output. Okay, and what are the use for the output? We have motors, we have solenoid valves, lamps, even buzzers are part of the output. Okay, so sensors. So sensors is a device used to convert physical variables into form and electric signals to gather data to monitor or control a process. Okay? So, muna siya ang gamit sa sensor, guys. Tanang mga, like for example, if you have this type of sensor nga mo-sense sa mga materials nga moagi sa iyang atubangan, either it could be wood, okay? So, later on, we will discuss this type of sensors. It could be wood, glass, metals, or non-metals, okay, that will be passing through the sensors. So, unsa may mahitabuan na, once ma-sense siya of physical variable, either wood, glass, or any materials, metals, or non-metals nga moagi sa iyang atubangan, okay, once makadetect siya ng physical variables, unsa may mahitabo is that iya na i-convert, okay, into a electrical signal. And kanang electrical signal, guys, duha naman nakabuk ang data na either 0 or 1. When we're talking about electrical, duha ra gyud kabuk data is 0 na 1 wala. Okay? So meaning ang sensor pwede siya mahimong counter. So kung natay conveyor diha nga mag-count og sa number of bottles nga moagi, glass bottles nga moagi din ha, So every time nga makadetect siya og glass bottles, mo-reflect na siya iyang sensor sa bottle. So depende o sa nga klase nga sensor ha iyang gamiton. So agya ng conveyor ana makakita siya physical variables, iya na i-convert to electrical signal. So ato na sa atong logic, sa ato ang timer baron, so sa atong relay baron gigamit or counters baron. So mo na atong gigamit sa ato ang control panel nato. So muhatag na siya data ngadto. So that electrical signal that will represents 1. So that will be inputted to our counter. So, mo-count na siya 1. Hantod nga, pila ka glass ang moagi sa conveyor nga gadagan guys, nga moagi sa atong sensor. Until it stop, it will count the number of bottles that's coming in. That pass by, I mean. Okay? So, muna siya yung monitoron. So, depende sa paggamit nato sa sensor. Pero ang iyahang setup lang yun guys or iyahang logic niya okay sa sensor is that whatever physical variables that pass through the sensor once the sensor captured it will be converted or it will be formed into electrical signal that will go through the controller. Unsa may nasa controller katong logic relay sa to timer or counter. So ato na siya i-gather ang data, okay, with that electrical signal. So kung walay physical variables, the electrical signal is 0. But if there is an electrical variables, there are physical variables that pass through the sensor, it will convert to 1. So that will be going to the control panel 1. Gather the data, okay. So from that way we can monitor. Okay, a certain process like counting. Okay, it can also check whatever type of sensor. There are types of sensor that we will be talking on later. Okay, so that's the use of sensor. Now, on types of sensor, guys, we have the contact sensors and we have also the contactless sensor. Okay, contact sensor, guys, from the name itself. Okay, that means it will contact or the sensor itself will be contact or will have a mechanical aspect. Either gatuyok siya, okay, that's why you have there as an example as roller. It could be a limit switches, okay, or a pressure sensor nga kinahanglan nga ma-reach niya, kinahanglan mo tugpag yun sensor. Okay, that's why it is called contact sensor. Okay, so it will be touches to the sensor before it will generate into a certain data into the logic until it will give you the output. Okay, so limit switches, it will like example for the limit switches guys, it will limit the like kanang mga kanang pull up rollers, okay, so that is automatic lang mga pull up rollers nga mga door, okay. So nana siya rollers sa babaw, okay, nga once it is the sensor of that rollers guys, nakuha na niya ang maximum nga kuha niya kanang sige na ni maximum niya nga limit, okay, maximum niya nga limit nga ma-reach na. So that means that's the time nga mo-stop na ang roller para mo abli ang door, okay, for using this mechanical aspect. Okay, but then again, in closing it, there's no problem. But in opening it, guys, so there are actually contact rollers there that can check the limit of the switch. Okay, so once it reaches to the limit na, so it will send signals to stop. Okay, it from whatever is doing. Okay? So mo na siya ang naa dito sa part of the contact sensors. Okay, so daghan. So naatay limit switches, naatay roller switches. So limit and rollers can be combined. And we have also pressure sensors. Okay, so pressure meaning ma-detect na to kung like sa water tank. Okay, so meaning kung ang water ubos na, so daas na siya dako nga space para sa iyang air, so meaning makalculate na to ang pressure, mas daghan og pressure kung ubos ang water level kay dako na mag-space para sa air, so maklar na nimo ang pressure. Okay? But kung mataas na ang water level sud sa tank, guys, so gamay na lang ang flow sa air kay gamay na lang ang space, so nasa mo gamay na sad ang iyahang pressure. So that means we can attach a pressure sensor at the bottom part to detect if kung taas ang pressure, meaning gamay og tubig, then we can also detect a pressure sensor on the upper part. That means if there is a less amount of less pressure na, that means there are lot of water already. Okay? So pwede na to na siya i-convert nga once ma-reach na ang ingani nga pressure, gagamay sa pressure, less water in the tank, then we can connect a buzzer for an alarm, gagamay na lang ang tubig. Okay? Then once it also reach the limit of the sensor that is very low, so kung gamay na ang pressure sa sensor, so that means the tank is almost full na, and then it can also connect it to a bus with low send signal that it's almost up. Okay? Puno na siya. Then we have also a contactless. So kung naay contact, naasay opposite, guys, which is contactless sensors. Now, when we say contactless sensors, guys, so these are the proximity sensors. So we have the reed switch, inductive, capacitive, okay, and optical sensors that we will be also discussing later on. Okay, so that means the proximity sensors, it has kung na siya ba, kung sa limit iya is, yung kita daw niya is approximate nga niya nga data. Okay, so this will detect the presence of an object without, in the contactless, guys, with the use of proximity sensors, it can detect the presence of an object without touching it. Okay, kung ang contact sensors, the sensors need to touch the object, but here in contactless sensors, especially in proximity sensors, it can detect the object without touching it. So these are the sensors, guys, that detect movement, okay, or presence of an object without making physical, or the object is not converts that integration to be captured into an electrical signal. Okay, so that means there's no harm. Okay, so there's no damage on the object. Okay, wala man na to hilabti. Okay, so muna siya ang nasa contactless sensors. So these are the classification of sensors. So you have here the sensors classification according to principle of operation. So in operation, you have contact sensors, electrical limit sensors, the pressure sensors. And in contactless sensor, you have magnetic, inductive, capacitive, optical, or ultrasonic sensors that is under the contactless. And sensors, according to wirings, guys, we will also be discussing here. We have the 2-wire sensors, 3 wires, and 4 wires. And for sensors classification according to output signal polarity, we have the PNP, or positive, negative, positive sensors. And we have also the NPN, or the negative, positive, negative sensors. Okay, or neuron, protons. Okay, so depende, parihara na gyapon ng meaning sa negative, neurons, positive, protons. Okay, so there. So we have the types of contact. Okay, so we have the brake switch, guys. So that means releasing the actuators to brake. Okay, so this is the opposite of the make. Okay, opposite na siya sa make. Then if you see the picture also, you see that it's an opposite. Okay, this is the opening the contacts to stop the flow of electricity. Okay, so this is for you to stop the flow of electricity, you need to have a brake switch. Okay, so this is like cutting off the connection. Now for the make switch, guys, which is the one in the middle, this is the act of closing. So you need to push it. Okay, so that means it is a normally open contact. To complete the circuit, it needs to allow the current flow. So you need to push the button in order to have a good connection. Now for the brake switch, since it is opposite man siya, so it is a normally closed switch, and you need to push the button in order to break the flow. And in the make switch, this is normally open, and you need to push the button to complete the circuit flow. Okay, and the changeover switch you can have here. You can either way of there are two ways of the process, and you just need to switch with whichever process that you wanted. This is on the Arispicas or Arispicas, so change over switch. So there are two processes connected to the switch, and you need to push the button in order to switch to a certain process, to the right process and left, okay, or process 1 or process 2. Okay. Now, for the input devices, guys, we have the push button switch. So a limit switch is configured to detect when a system's element has moved to a certain position, and a system operation is triggered when the limit switch is tripped. So if you see this one, guys, you see the red color. So you have the red, yellow, or amber, and then green. So so normally, so makita na to na siya sa mga traffic light, but we can also see that one right now in our process na when we will be doing automations using pneumatics, electro-pneumatics in automations at a certain process, industrial process, we already see this, okay? That means we need to break it when we need to stop, okay? Reset, okay? When you have it in yellow, and then go for, make it for green, okay? And you can see here, guys, their connections in terms of switches here. So that is how it is look like. So if you notice, the red one is a normally closed, okay, switch, and then you need to break it in order. That's why it always once there's power on it, it will automatically turn red. Okay, so with the previous discussion that we had last Monday, we also used that once it is normally open contact, it triggers the red, it triggers the red color, and then once it is pushed, it triggers the blue color. Okay, so pareha na siya ni guys. Okay, so ang yellow na guys, the amber, that's the decision if it's stop or go. Okay, so muna siya ang iyahang changeover. Okay, so from red, it will go to yellow and then change to green. And then from green, it goes to yellow and then change to red. Okay, so you can see there, the first switch here that we have, this is the brake switch. Okay, so that is the red one. So if you're going to make it, okay, this one to make it, to push it, it will go green. And then go back to this changeover switch and then go back to the yellow one is the changeover switch, wherein it goes back to the yellow first before it changes to red, and then go to yellow before it changes to green. That's the thing that we see, guys, in our street lamp or our traffic lights. So we have here limit switch. So the limit switch is configured to detect when a system's element has moved to a certain position, and a certain operation is triggered when the limit switch is tripped. Okay, so here you can see here, guys. So once it is flattened, that's the limit of the switch, and that's the time it will trip. Okay, so you can see it is a copper metal. Okay, that will that will cut or the presence of the flow of a certain process once it reaches to the limit. Okay. Now we have also here the roller switch. If you notice here, you can have here the roller here on the top of the switch. Okay. It has similar with the limit switches, guys, but then what is just different here is there is a roller on the switch. So it has a little lever with a wheel that activates when something moving past it. Okay. So when there is something moving past through the switch, guys, so it will trigger. Then next you have here is the reed switch. Okay, so a reed switch is a commonly employed for sensing the position of a mechanism, that movement of which is to be monitored, by providing a switch output response to the message of approach of actuating magnet carried by its mechanism. Okay, so this is how you can see in the On the reed switch, guys, so we have here a normally closed and normally open. Okay, here. So this is a normally closed switch and this is the normally open switch. Okay, so you can see here the break, the make, and then um, the change over switch. Okay, so there is actually it is actually an electrical switch, guys, that is operated with applied magnetic field. So what you can see here inside, okay, on this, so this is consists of a pair of ferromagnetic metals that has that is inserted to the plate. Okay, so na siya, manay plate siya, and so the glass. Okay, so it has two types of plate, guys. So we have here the normally closed and normally open, and then it can be changed into each of the type of switch. So you have here inductive proximity switch, guys. Okay, so we have the inductive and the conductive. Okay, so these are actually metals of object. You can see here, guys. So that can detect here if it is a any moving material. So it is an electronic proximity sensor, which detects metallic object without touching them, and it uses electromagnetic field in order to sense the object. So this is the sensor here, and it composed of the process here, the logical controller, at the same time the power connected to it for the transmitter. So you can see here, it is a transmitter actually, or the transistor that you can have here three prongs. Okay, and for it, this is actually a PNP or positive, negative, positive type of transmitter. And once there are metals or non-metals that is going or passing through the sensor, it will really detect. Okay, and again, it depends, guys, on what process that you're doing. If you're going to have it to have this sensor as counter, okay, or to have this sensor as detector, that there are actually numbers of object that is passing through it. So depending, okay, because once it detects something, okay, it could be an input, and then it will be processed to the logical component, and then it has a generate output. Okay, so parihan ni siya, guys. Like for example, ang atong automated door. Okay, so instead of opening it and closing it with a security guard, you can just use the sensor if someone is or any object, even person, guys. Sa inductive, kay metallic objects lang siya, pero nasa tayo lubang sensor nga, it can also detect any other type, okay, maski tao. Okay, so there, to detect. And it has also like kung dili man gani ka-detect sa person, then we can use another sensor like butangan. That's why you see it on the door, guys. Ang metro magid ako example, no, kay mura may dodo sa mga nga mas troyan sa liluan. So if you can see there, guys, there are also metal floor before you can reach the automated door sa metro. Na siya metal floor. So more pwede na siya mag-imong pressure sensor nga kung nanadali nagbarugan na. So once there is already load in it, so mo low down na siya. So there's pressure. Okay? So mo nang mo open ang door. Okay? So it really depends on what type of sensors. So there are a lot of sensors that we can use as long as we know their characteristics, then we can actually use them in our automation for the certain process. So for the capacitive proximity sensor, so proximity sensors would boost an electroelastic field to sense object. Okay, so kani siya ang inductive or metals ang iyaha. So kani object, any object. Okay, so it could be capacitive proximity switches sense metal as well as non-metallic materials such as paper, glass, liquid, and cloth. Okay, so for inductive, it's only metals that can detect all types of metals, but here in capacitive, we have different types of non-metallic metals and even metals that can be sensed. So for photoelectric sensors, guys, so when we say photoelectric sensors, so these are actually devices that uses light, to detect the presence of or presence or absence of an object. Duha, either it could be presence or absence of an object. So nana siya light daan. Okay, so from this one you can see there is a light from the transmitter and the receiver. Okay, so there is already light connecting to that. So once any object that passing through it, it will cut the light. Kaya na may object na mugawas. Okay, so with that will send signal. Okay, that there is an object that passing through it because it cut off the light connection. Okay, so can be used for automotive, food, transportation, and material handling industries. They are using this type of sensor, which is the photoelectric sensors. Okay, and it can also detect, guys, aside from the other objects. Okay, it can also detect like metals, plastics, okay, liquid or glass can be also detected. For the ultrasonic sensors, guys, so this measures the distance from two. Okay, so this one are the example of the electronic sensors. So used to transducer to send the receive high frequency sound. So ultrasonic, it is using sound signal. Okay, when the target enters the beam, the sounds, it reflects back to the switch and causing to energize or de-energize the output circuit. Okay, so sounds sa iyahang gamit, guys, it has a receiver and a transmitter. So if you see there, duha siya, receiver and transmitter, because once magtupad na siya, guys, once it produces sounds, and once there is an object that goes to it, it will ma-feedback man ang sounds, guys. Mo bitaw nang mura siya gikuha siya daw, guys, sa kanang mga sa kwaknit. Okay, di ba? Di mo na sila kakita. Okay? But they're just using sounds. Okay? Kung reflect ganina ang sound sa ilaha, meaning there is an object. Okay? Munang dili na sila mabangga, guys. Kaya nga no, ang ilang gamit nila is mura sa gingani ultrasonic. Okay? So sa sensor pa. Okay? So once the target enters, musud ganinang object, mo reflect ang sounds, kay di bangga sa object ba. Okay, so mo nang mobalik sa receiver, gikan sa i-transmit niya sa sounds, mobangga na meaning there's an object yet, it will goes back to the transmitter and that will signal the output circuit kung iya ba i-energize or de-energize, depend sa imuhang gamit sa sensor. So these are other types of sensors we have. We have the level sensor here. Okay, we can use this on the water level. We have also here the depende kung sa gauge ba din mo, guys, ni mo i-connect kung low na, detect if it's the level of the water is low or high. And this is also the sensor that we will using in our sa kanang mga dam nato, okay, to detect kung ubos na kayo ang water, okay, or taas na kayo sa dang water. So we're using level sensor. Okay, and this is also what we have, the flow sensor. So it will detect the flow. It could be the process. Okay? So, depende sa gamit. And we have also the pressure sensor here. So, it will detect kung na-pressure sa babaw. So, as what I have mentioned a while ago. So, if there are actually people standing on the metal floor, okay, it will it will detect the pressure. Okay, nasa babaw nga nagduot niya. So, mo na siya, it will trigger the door to open. Okay, or to close. Kung walay pressure, close. Kung may pressure, open. Okay, and we have also temperature sensor that will detect the temperature and then it will go signal to the output or whatever it is connected to. And we have also the float sensor, guys. So makasagaran na siya gamit sa kanang mga nagamit kinanglanon sa tubig nga mo float raman siya. Okay, there. So, sa sensing device, guys, of an inductive sensor, so this is the distance. Okay? So, for copper, we have 32%. Okay? The aluminum is 36%. Brass is 50%. Ang sensing distance niya. And then, chromium and nickel, we have 70%. And then, the all iron is 100%. Okay, so this is the sensing distance of an inductive sensors. So for input devices, so we have switching distance. Okay, so it is defined as the actuating distance between the object and the sensor. So the switching distance is depend upon the actuating object. Okay, so we're using the proximity sensor here. So we have here the sensing distance. Okay, so from this target to here, okay, so you can see, but kung layo man gud kaayo ang imuhang, kung layo kayo imuhang proximity sensor, guys, dili na siya ka-sense sa object that is going through it. Okay, so if there is no object, it will be turned off, but if there is an object that is passing through the distance, okay, it will trigger on. Okay, and then after that, it will reset the distance once it passed through. Okay, so if you see here the reset distance to turn it off, and then it has the sensing distance once it is on. So this data here in the sensing distance and the reset distances are the data that will be going through the controller. So that is our logic controller. So from there, it will be analyzed. It depends on saan na ito paggamit atong sensor. So we can generate the output. So these are the applications. So you can see here the sensors that can detect, okay, the presence of the brake drill bit pwede. Detecting the presence of the set screw on hub for speed direction. So i-detect kung kompleto pa ba ang set screw para mag-rotate for speed control. Okay, so there are also sensor application here in detecting the full open or closed valve position here. So if it's already here, so depende, open na siya, but if it is already here, so that means a closed valve. Okay, so if it's a closed valve, it will give signal to it, and then it will go to sana sa isunod niya nga process na connection. Then this one, it could be detecting if it's open, and it will go to another process connection. So here, this is an application of detecting milk in cartoons sensor. So it can detect liquids inside the cartoons. Okay, so you have there the sensor capacitive sensors. Okay, so you have here sensors also, guys. This one for controlling a fill level of solids in a beam. Okay, so this is also a type of capacitive sensor that detects the level, okay, of the solids. Okay, so pila ng bus baron sa baron kinahanglan i-detect. Okay, so this is an application of detecting presence of can and lid. Okay, so babaw, so kunaya. So this sensor that will detect that there is the presence of a canned goods, and this one, the sensor on the top is to check if it is open or if it is closed already or sealed. Okay, so muna siya iyahang gamit. So there are actually a lot of types of sensor, guys, and we are seeing those already in the devices that we have purchased in high-tech power, especially the 5 mini process automation that we had the last 2 weeks ago when we had our training for our new device using PLC as the controller. Okay, so nanangatutanan yun, guys. Okay, there are a lot of types of sensor there. So in sensor connection, guys, so we have connecting a 2-wire sensor. So 2-wire, guys, represents this wire here, the 2-wire that's coming out to the sensor. So this is a 2-wire 2-power transmitter. Okay, so what is the advance? So it has the analog output card, guys. So this is where we will be having the control panel, and this is the power supply. Okay, so the advantage on a 2-wire power transmitter is that it uses only 4 to 20 milliampere with 2 wires only, and then low power consumption since we have only one power supply, and it uses it was one power supply to supply power for the controller, this one, and the transmitter. Now the disadvantage of this is that once it runs to a signal of electromagnetic field, guys, it is not suitable for 0 milliampere fault detection. Okay, so it cannot detect. Okay, there is a fault signaling that cannot be set on 0 milliamperes. So this is not suitable for control panel that required to detect a fault detection of 0 milliampere. So kung nakaset imong control panel nga mo detect po siya at a 0 milliampere nga voltage, okay, or kanang current, I mean, so dili na siya ka detect. Okay, so mo process ang mga problema niya mo flow gihapon na mo padayon gihapon yung process kay di siya ka detect if using a two-wired loop power transmitters. Okay, so it continues to work in a 0 milliampere current. Okay, now for the connecting a three-wire sensor, so here you have here in the middle. Okay, so this one is the most common 4 to 20 milliampere connection and utilizes only the three common three cables with one power source still with a common power source for the transmitter and the control panel. Okay, so that's the only advantage. The disadvantage is that the electrical interference can be transmitted along a signal line which could generate false alarm in the control panel. Okay, so once it's running, guys, here, it's running here. Okay, so once it's running here, if there are electrical interference or electromagnetic interference that's running to the line, okay, so it might generate a false alarm to the control panel. Okay, maghatag siya false alarm even if there's nothing wrong with the process. Okay, so mola na siya. So current source, transmitter, non-isolated, it's a three-wire sensor connection. So the other one is the four-wire sensor. So this is a fully isolated four-wire transmitter. So electrical interference. So any electrical interference that's running from the control panel even to the power does not affect or it doesn't have any reduced risk of leading false signal to the control panel. Okay? Because it has a separate power for the transmitter. Okay, so what's running here is only the power for what's running to the control panel is only the power for the control panel itself. So if you can see, it has a separate power for the transmitter and a separate power for the controller. Okay, so that's why you can see it has four cables. 1, 2, 3, 4. Okay, instead of two cables only to transmitter. So you can see what's outside the transmitter right now, how many cables that's connected to it. Literally 4 cables. That's why it is called a 4-wire sensor or fully isolated 4-wire transmitter. So for the output devices, guys, so we have here lamps. Okay, so this lamps here that has the red, amber, and green. This is the lamp that we are using right now in our automation, industrial automations that we had. The 5 process that we automate in our laboratory. So this is to check the presence of the current state of the machines. Okay, so if it's in a green status, that means it is ready to go, and if it's in a amber or yellow, that means this is a changeover switch. So that means you need to change if you need to reset it and start or stop the process. Okay, and if it's a red light, that means it stopped the process. So these are the output indicators of the output indicator devices with the use of lamp. Okay, so it's a thin wire filament which become very hot and grows brightly when it current passes through it, and the filament is made of metal and high melting points such as tungsten, and it's usually wood into a small coil. Okay, so that is an output indicator, guys. That's the which indicates the type of status, okay, so that you all have currently in your process. So we have also buzzers. Okay, so these are buzzers used as indicators. An audio signaling device like a beeper or a buzzer may be an electromechanical or piezoelectric or mechanical type. That main function of this is to convert the signal from audio to sounds. Okay, so this could be another output indicator. Okay, for us, after we done a certain process, okay, after having those sensors connected, so you can choose whatever your output indicator is. So what we have right now in our laboratory is the only for lamp. Okay, lamp atong gigamit for uh, sa ato ang kanang output indicator. But here, they are used instead of lamp. Okay, it depends on the process that you have. Okay, that you're using and your automations and your process in the industry. You can use this another output indicator, which is a buzzer. Okay, so literally means squeeze or press na siyang piezoelectric type. Okay, so we have also motors. Okay, so this is mechanical. Guys, when we talk about motors, it's all about mechanical aspect. Okay, so motors are machines that produce mechanical movement when supplied by electricity. So this motion caused by the interaction of magnetic field and current carrying conductors. So after our input and we process it in our logic circuit, guys, or in our controllers, then we can generate an output. It could be connected to a lamp as an indicator, a buzzer, or it can be connected to a motor to start another process. Okay? So, matuyok na ang motor to connect a certain process or sa napusunod process ang atong gamiton for the automation. So, muna sa na siya yung next step. Okay? So, the one that we have there is a 5 steps or a 5 process that is connected to one another, from distribution to testing, to processing, indexing, and sorting. So, those are 5 processes. And in the middle of that process, guys, there are actually motors that's connected to it in order to do a mechanical movement. Okay, especially the swinging of the arm, okay, from left to right, connecting to the next process. Okay, so there is really a mechanical movement. So that is an output device used for motors. So we have also a solenoid valve. So kaning solenoid valve, this is an electromechanical. So nasa gyud po na siya yung tuyok, guys, parehas sa motors, but then again electrical lang siya ang iyang driving. Okay, it needs to have a push button, electric button to that is connected to a current. Okay, munang gitawag siya electromechanical valve. Okay, that control the flow of liquid or gas by running or stopping an electric current through a solenoid. Okay, which is also a coil of wire, same as motor, but thus changing the state of the valve. Okay, so yung gamit din sa motor niya is to change the state of the valve from this current to another position, from this position to another position. So these are an example of a solenoid valve, 5 two-way valves. Okay, so you have here, guys, you see the pilot 14. Okay, here you have also here another valve. So for 3 two-way valve, the directional control valve, solenoid actuated with spring return. So you can see it here. So for 3 two-way, we have 2 types, guys. We have the normally closed and also the normally open. And we already used this in our last exercises that we had prior to midterm. So we already using it from one of those 9 exercises that we had. Okay, so the solenoid valve is controlled by applying a voltage signals at the solenoid coil. Okay, so this is what I have mentioned to you a while ago, that after we use this certain connection to our cylinder and connect this one to our compressor, so that is pneumatic. But once we use the solenoid already, we need to have a voltage to have it work. So that's why we have electro-pneumatics. Okay, so the flow passes freely from 1 to 2 when normally open, and by stopping the signal of the valve set back to the starting position through use of spring return, this one, connection 1 is shut. So if no signal is applied to the valve, it can be can be manually operated, but this valve is derived from a configurable 3-way valve. Okay. So we have also the 5 two-way valves, okay? So direction control valve with spring solenoid actuation with spring return. So same concept, guys. Okay? Similar na sa itong ikamit. As long as there is a solenoid valve, we need to have electric, and that is the one that we can use in order to actuate the solenoid by using a push button switch. Okay? And a spring return. So here, we have here the double solenoid actuation. We have solenoid here and here. So dili na siya spring return, guys. So these are the the other type of two-way that you have that you need to manually push to turn it on and manually push to turn it off. Okay, without the use of spring return. So logic devices. So we have relay. So relays is an electromechanical switch that will trigger by supplying electricity through its coil, and when the relay coil is energized, its contact will switch to an opposite state. So if it is in a the purpose of electricity is to let the coil energize and then switch it to an opposite state. So meaning kung naka-on na siya with the use of relay, we can turn it off with the use of the electromagnetic switches. That will trigger the state of the relay to whatever opposite position it is. Okay, with the use of by supplying electricity. So these are the relay. Okay, so we can have many ports. Okay, if you want, depending kung yun sa nimo paggamit. Okay, so mo na siya, if we will use relay, guys, kaya dili ka afford of PLC to do the program, we can use relay. We can connect lots of wirings. So mo na siya, kung madlipog ka maswito sa wirings, malibog ka, madili sa nudagan ang imuhang project. But if instead of having all those wirings and lot of relays in order to change ma-input sa diri mo, change po sa current opposite position niya mo, that will be another input to another process and everything. So daghang kag relay nga gamit, daghang kag wiring nga gamit. So we can remove all of this relays and wirings, and what we can do instead is to inject PLC and then program it there, and then there will be no more relay to be used. Okay, there. So for the functions of a relay, so it is a voltage change. So from there also change from gikan sa 1 to 10 milliamperes. If you want to go it down to 5 milliamperes, we can do that, or the other way around. It could be a power amplifications to turn it off and turn it on. It can do logical like multiplications and logic like and or not, and also memory latching. That is what you can do in these functions for relay. Okay, and we have also timers. Okay, so these are the logic devices already, guys. Okay, so relays, timers. Okay, so there are types of relay that delays the switching of its contact and adjustable specified time. Okay, so we can delay with the use of relay. We can delay the timers, guys, from 30 seconds to 25 seconds. So it depends on whatever you need to use it. Okay, so depende sa imong paggamit. So here, we can have it switch off delay. Okay, so that is actually what we do on the last activity that we had from I think it was activity 8 or 7 when we do the off delay and the on delay. Okay, so we use timers. So it is already in a logical timers, guys, nga ato na magamit sa ato ang circuits and pneumatics nga na siya daan, pareha na siya sa valve. Okay, na siya daan. Okay, so pwede na niya ma-delay, and we can for the timers that we will going to connect, we can set time as well. Okay, kung pila ka minutes or seconds nga ato ang i-delay. Okay, and that is in a logical circuit inside to it. Okay, so we have also counters. So these are an example of a counters that we can use to connect. Okay, so pwede na to na siya i-connect, guys, sa ato ang kanang sensor. Okay, para maka-count siya pila ka bulk bottles ang niagi ngayahang na sense. So our counters are electromechanical switches that are capable of counting, storing numbers, occurrences where a particular signal happens. Okay, so these are utilized, guys, with gamit niya is an electronic magnetic field, okay, nga electrical components nga mohatag og data sa iya to count those with the use of sensors nga atong gamiton. Okay, so if since it is an electromechanical, so with the use of electricity to generate 0 and 1 only, okay, so it will do the counting. Okay, so the relay pickup after the predefined numbers of current pulses has been encountered between the connections A1 and A2. So if a potential is supplied between a connections R1 and R2, the counter is reset to its predefined value. Okay? So kung na siya yung connectors here in between R1 and R2, so it will reset, okay, to what is the current value. And the simulation model, the relay counter can also be reset by clicking on it. Okay, so there. So mo na siya, guys. This is an example. So if it's 15, if there's something object coming in and it will connected to the sensor will send signal to the counter and the counter will do another count. Okay, so from 15 to 16 and then 16 to 17 and then to 18. Okay, so depende, guys, kung ano siya, kung saan sa lang nagamit nimo sa imong process. Okay, so I think that's the end of the slide. So we have only about the 3 logic devices that we have. So we have the relays, the timers, and the counters, and we already discussed about our input devices. Okay, and our output devices also are also discussed. The sensing devices and then the sensor connections we have. Okay, the 3 two-way, the 3 connections, 2, and here 2-wire, 3-wire. So these are the things that we have just discussed for today, guys, about the sensors classifications, contacts and contactless, okay, for the input and the output. Okay, so any questions? And by the way, guys, this slides has been uploaded already to our Google Classroom, so you can check it out there. Please study on it so that you can be ready for our next meeting on Friday. I will open you a quiz, guys, on next Friday before we will going to end our December for the holiday. Okay, so I'm going to meet you Friday morning, guys. Okay, so hopefully yun kung napata sa classroom, then we can enjoy our Christmas party before na magbakasyon sa atong mga probinsya and enjoy our holidays with our family. Dili lang ga, Rafa, dili mag semifinals lang ga, mag-quiz lang ko lang ga. Okay? So I will meet you Friday morning, next Friday, guys, 9 a.m. in the morning. Okay, and then I will meet you first before I will give you your quiz. Okay, it's not a semi-final exam, but it is a quiz. At the same time, mahatag na sad siguro na ako ang utang ninyo, guys, na perting ng Lugya, which is your midterm grade and your midterm output. I will give it to you before the holidays. So that's the thing that I will be doing this coming Friday, guys. So just study. I already posted in our Google Classroom. Study what we have discussed today, and I will give you your quiz next meeting. Any questions, mga langga?